and we're going to create a population of people. How do we do that? This is very important, and this is going to be a skill you're going to see again and again and again in the coming days. Once you master this, it's quite simple. So go to main, make sure main is shown, and now you are going to click on person and drag it over to main and let go. Okay? Just like you did for things on the canvas, you will instead do it from the projects. Okay? Now, ladies and gentlemen, having done that, you'll notice it's waiting for a name. I'm going to type right now population. But you'll notice, ladies and gentlemen, that that if I didn't do that, if I just left it by accident that with that original name, I could always click on it, go down to properties, and rename it here. Let me illustrate that for those who are wondering what I'm talking about. So if you were to do this and somehow mess up and not rename it, I could always go click on this, go down to name in person, and call it population. Okay? Okay. Now, ladies and gentlemen, that act does not by itself, that act of naming, despite its evocative character, does not in fact make it a population. Looking at this interface, what things do you need, what do you think needs to be done to make it a population of agent? Look what it's asking us up here. What do you think needs to be done? Again, a very common need.
Click the population.
Click population of agents. Having done that, it's going to ask how big will this population be. We're going to come back to that. Leave it as 100 for now. Are we okay with this? Ladies and gentlemen, a population is going to represent exactly that, a population of agents. Okay? You will notice that with this population, we're going to be able to specify many things. We're going to use this population to specify the characteristics of the people within that population. Person describes a theory of personhood, but within this population, we're going to be specifying the particulars to assume in terms of the characteristics of each of those people. They're each a person, but we're going to specify the particulars of them for each population. So for this population, you notice where it says age, we're going to set it to uniform, 0 to 80, okay? Or where did this come from? Who wrote that? You did, indeed. You created this. This is what you created earlier. You said, if nothing else is typed in here, use that. So we'll accept that. That's fine. Okay, ladies and gentlemen, congratulations. You finished your first model. Let's run this thing. Okay? Okay. Let's run this model. Okay? And the model will be uninspiring at first, but it'll contain seeds for growth. Okay? Ladies and gentlemen, I just ran it. How did I run it? I right-clicked on this. I clicked Run. And then I clicked Run. Time is progressing. There's actually nothing going on in this model. It's static. But you could go up here, and you should be able to click and go down and see population. And here, ladies and gentlemen, is a depiction of each person in our population. Okay, now this is interesting because I would have expected each one to have a clearly visible age. Give me just a second. Oh, okay, ladies and gentlemen, do you see age? I'm sorry, ladies and gentlemen. Something I'm wondering if I did something wrong or if it's afflicting all of us. Can you tell me when you run this model and you click Run there, and you go and you click on this to go down and see the population, do you see a parameter here? You do. Yeah. Okay, so I must have accidentally clicked in person visible no here, because on mine I couldn't actually see it. I must have clicked visible no. I want to click visible yes, which is the default, as I recall. I don't remember that happening before in any of my boot camps, of which there have been numerous. Okay, ladies and gentlemen. So I'm going to go down to population. Here's one person, age 58.47. Here's another 16.617, 77.42, 77.0, 75, 31. Do you see that? Okay. So ladies and gentlemen, you have a heterogeneous population. Okay? Now, I want to teach you some more principles. How did we specify the age? Using what any-logic construct? What any-logic building block did we use to specify age in person? A what?
Uniform distribution.
Yeah, it was a parameter associated with a uniform distribution as specified for that particular population. Okay, it specified a uniform distribution here to assume for it, but the particular mechanism, the building block, was a parameter, the construct. Now, parameters are extremely useful to parameterize things, to tell the model what assumptions to make and to communicate those assumptions to the model or to an element of the model. So, ladies and gentlemen, to reference this point, suppose that we want to allow this model to have different population sizes. How could we have different assumptions? So a parameter specifies assumptions about a situation, okay? We have person, and a person has an age, and that's the assumption about their age. More than that, a parameter not only encodes an assumption, and it communicates that assumption from where the object is created to it. So for example, in main, population tells each person what their age is, okay? The parameter is used to communicate that assumption from the population to the person. So suppose we were in main and we want to have an assumption for main about how big the population size is. What can we use to encode an assumption? A parameter. So let's go add a parameter to main, and it will be called population size, okay? Okay. Now, in general, it's a very good practice to encode assumptions in parameters because it allows you to change them, to see them explicitly rather than hard coding them. If you hard code them, they might appear many places, and you might remember if you want to change them to change most, but you'll forget some. And it's much better to have one parameter to encode them. So let's drag into main. How did I drag that in? I dragged it from this agent palette. Let me do that again, because I know I do things too quickly sometimes. So I went over to the palette. First of all, I called up main by double-clicking on this, and then I went to the palette. I went down to the agent palette, and I dragged in parameter, just like this. Boom. And I called it population size. Okay, now, population size, ladies and gentlemen, is going to encode our assumptions about the size of the population. Now, just like I did before, and just like I will do many times in the course of this week, I will ask you, what type do you think this is? Is this population size going to be a floating point value? What do you think it would be? An integer. It'll be a count, ladies and gentlemen. So it's going to be an integer, okay? So we're going to say it's an int, okay? Int. And its default value, if no one specifies it, if it's not specified, and we'll see where it's specified in just a minute, will be 100. Now, ladies and gentlemen, in our very first example, we actually did specify a parameter. We specified the parameter value to use. We actually changed it. It was for contact rate. Do you remember that? We changed it from 1 to 0.95. Do you remember that? Mm-hmm. Where did we specify that? Wheretofore was that in the model? It was in the... It was in experiment. So let's go to experiment now. Over in projects, let's navigate to experiment. And over in projects.
Oh, yeah, right. Population.
And you'll notice there's population size, okay? Now, ladies and gentlemen, let's go add a new experiment. Boldness, ladies and gentlemen, boldness.
Copy?
Okay, we could copy. This is one good way. We could copy and we could paste. Now, why would we do that? Well, in general, if we have an experiment where lots of the parameter values are going to be the same, we only want to tweak one, we'll often do copy if the, so we do right here, click here, copy, and then we click up here and do paste. Okay, so that will be one. And we're going to call this new simulation experiment big population. Okay? Okay, that would be one way to do it. And its population size, ladies and gentlemen, will be 1,000. Okay? Are we okay with that?
Why is it saying that?
Okay. 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 So, who would like some help?
I think I've got it.
Okay.
I picked up a database.
Oh, you did?
Yeah.
Well, that's. I think you're using 7.2.
Yeah.
I think it automatically is included in there. So no worries. No worries. If you see a database hanging around, it's probably because you're using 7.2 or 7.3. AnyLogic 7.2 or 7.3. And we can talk about some of the issues with those later. There are opportunities and the risks. Okay, so ladies and gentlemen, do you see population size there? Just to rehearse, what did we do? We went to palette. We added in from the agent part of palette parameter. It's actually in several parts of the palette, several other palettes. Added in parameter. And ladies and gentlemen, for this parameter, we made it an integer of default value 100. Now, what that 100 means is if we don't specify it, it'll be 100. But if we do specify it, we can specify it to whatever we want. Again, a parameter encodes an assumption to use and communicates that assumption from the point where the thing is being created, where main is created by the experiment. So experiment communicates 1,000. Meanwhile, a person is created by the population, and so they're told by the population what to assume for the parameters of person. It tells, assume this for these parameters, or that for these parameters, okay? A parameter encodes assumptions and communicates the assumptions from the point of creation. Okay? Important. It'll be different from a variable, which is going to change over time and characterize things as they evolve. Okay? Are we okay with this? Let's run this model. Let's run the big population. Okay, run. Okay, here we go. Okay, you'll notice, ladies and gentlemen, something crestfallen has occurred. Here's our population size. It says 1,000, but why does it say a population of 100?
Because we didn't change the.
We didn't change it. Ladies and gentlemen, AnyLogic, this is an abject lesson. AnyLogic will do exactly what you tell it to do, which might be quite different from what you want it to do.
How did I get 1,000?
Okay, because you probably finished the job. Okay?
Something strange.
Okay, no. I think you finished the job. What do we need to do to actually, so this says population size, and we said 1,000 for it, but what didn't we do? We didn't make it actionable. We didn't actually make it use that value. Where does it need to use that value for it to actually be the size of this population?
In main.
It's in main, and where do we go to make it the size of this population? We go to the population. In general, ladies and gentlemen, if we want to change the attributes of something, an oval, for example, we'd go to where the oval lives, like in person, and we click on the oval. If we want to change the characteristic if we want to change theory of personhood, we go to person. If we want to change something about main, we go to main. If we want to change something about the population, we go to the population. So here, what would we change to make the initial number of agents be dictated by the population size parameter?
Change the initial number of agents to population.
Indeed. Initial number of agents, ladies and gentlemen, here should be population size. Okay? Are we okay with that? Ladies and gentlemen?
Oh.
The default value
No. Well, okay, yes, sorry. Okay,
You're on-
initial number of agents is population size. The default value of parameter population size is 100. Remember, we're in population. We're in population here. And the population here has initial number of agents being population size. Does that make sense? So whatever's in the parameter population size, it's going to use for populations, the number of agents in the population. Are we okay with that? So remember, just because you add something in called population size doesn't mean any logic knows what to do with it. You have to show, okay, you have to complete the thought. You have to complete that logical chunk of work. You add the population parameter in, population size, make it the right type, set a default value for it, and then you need to actualize it by making the population have that population size. Are we okay with that? Okay. Okay, are we ready to run this? Let's run it. Ladies and gentlemen, let's run this. Let's run it. Okay, now we should see a population size of 1,000. Do you see that? Do you see that? So what did I do? Let's just go through this again from the start. I added a parameter called population size, called it int, made its default value of 100, and then I went to population and I made the initial number of agents be population size. Please remember that basic pattern. Add a parameter, it's an integer, encoding the population size, and then make the population have that population size. We're going to use that again multiple times in coming days. Okay? Yes?
Default value to 1,000?
No.
That's
No.
in big population model.
So yeah, let's be clear what the default value is. This is actually really important. Okay? If this parameter, so the default value just says if there's something which needs to specify the value of this parameter, what value to use, what expression to use to determine the value if it's not specified there. Who is it that specifies the values of population size? It's experiments, ladies and gentlemen. Different experiments. The point of making this a parameter is we want to vary it across different experiments. That's why we parameterize out. Before, remember, we just had a fixed value of 100 here, right? But we don't want to have to change that to 1,000 every time we want to experiment with the model with a parameter, with a size of a population size of size 1,000. Instead, what we want to be able to do is to create different experiments for different parameter sizes. Let's create another one, okay?
Is there an advantage to entering a default value though? Because if you didn't enter that, then you would get an error when you didn't connect it, and it would kind of
Not.
you to connect
It's a
it.
great question, and I'll tell you a secret, okay? Maybe I should stop recording here, but I'll tell you a secret. I actually don't tend to provide many default values for things in my own work, and it's partly because of that. But there are times where if you forget, it actually just gives it some other value, and it doesn't warn, which is not good. And so recently I've started to be more careful about that, because sometimes what happens is I add a new parameter in and I don't give a default value, and maybe I have the thought, oh, I'll just always fill it in, but I forget. Maybe I get a phone call, I'm distracted, and I forget to go fill it in the experiments that are there, or I forget to fill it in the population, and I just leave it there and forget about it, and then the next day or 2 days later I discover, oh, I never filled in values for it, but it runs, and that's not a good thing. If it's a problem, you want to know it as soon as possible. You see what I mean? And I think a default value will help. Okay, ladies and gentlemen, let's add another one. Okay, let's add a new population. I'll show you another way to add an experiment. New experiment, and let's call this let's call it bigger population, okay? Let's make it a population of size 10,000. Okay, 10,000. Now, the key thing I'm trying to communicate here, and this is the key point, is by turning things into parameters, you can make different assumptions about them. And particularly if they're parameters in main, you can make different assumptions in different experiments. And that's what you want. Every time you want to run a different what if, you don't want to have to go back and change the model. You just want to be able to create an experiment you can run time and time again, with a big population or a small population or medium-sized population. You'd like to be able to just run it with different assumptions without going and changing the whole model. You just make different assumptions about it. And remember, an experiment is a scenario. It describes what to assume for this run of the model. So by putting things into parameters, we can assume different things about them for different experiments. That's really the essence of it. Let me repeat that again. To repeat that again, by putting things into parameters, we can assume different things about the parameter for different experiments. Okay? That's an extremely important point, and it's one we'll return to. We'd like to be able to just have different what-if questions for different experiments where we ask, what if we run the model with these assumptions, those assumptions? By making them into parameters, we can easily do that. Yes?
You had a question about if you create these experiments and then you're refining your model, maybe adding a population or something, that all carries through into the experiments you've already created, or do you have to go back?
This is a great question. So the experiments will remain there as the model evolves, okay? And let's suppose that you change the model by, say, adding a new parameter to the model. It will be automatically added to all of those experiments that are there. Now, this is good and it's bad. It's good in the sense that you don't have to go back and somehow manually add it to every experiment. It's bad in the sense that you don't have the automagic ability through an experiment to run an old version of the model and get those results, and then for newer experiments run the new version of the model. You don't have that luxury. And so basically the experiment is running whatever's the current version of the model with those assumptions. And let me sharpen that one bit more.
So are you telling us we have to discipline ourselves to save the model under
You got
a tweaked name?
You got it. You got it. And that's saved for the best practices part on the last day.
Okay.
Or one of the later days anyway. So, ladies and gentlemen, save early. Ladies and gentlemen, save often. Save with different model versions. So if you complete a chunk of work on a model, save it as a new version of the model, so that you can go back. If you submit that paper or that policy briefing with a certain version of the model, you want to be able to go back and reproduce exactly those results with precisely that version of the model, precisely the same assumptions. And the way to do that is to save away successive versions. Now, there's sophisticated tools that we use in software development, tools like Git and Subversion, that allow you to do that beautifully without littering your disk with successive copies of the model. But at the least, just copy your model, call it version 1, version 2, version 3. And you might, in fact, I would strongly encourage you to even have a variable called version number that you keep incrementing, you keep there, and when you save results away, you record what the value of that is. Now, I will tell you, we have a tool which our group has developed, which automatically, every time you run the model, it produces the results. It automatically records the value of parameters that are used for it, and it makes a complete copy of the model used to produce that, which allows you to save away automatically when it's run the assumptions, the random number seed, the copy of the model used to produce that. Okay. It's not totally foolproof because it could still be reading from a database or something, but it's a still very good way of keeping around a reproducible model result. And in general, you're going to want to store metadata when you produce your results, where this came from, what version of the model, and what assumptions were used to produce it. Or else the best of results might be gibberish because you don't know, well, these are results, but for what assumptions? Okay? Okay, so ladies and gentlemen, now I will also note, per Vivian's instructions, that we have strongly urged, we have exhorted AnyLogic to have a better version management system. And for the next version of AnyLogic, I believe, 7.4, I think they'll be rolling that out so that we can automatically keep track of model versions as part of AnyLogic.
I was just, as you were talking before you suggested you guys had save, I can just say, like, otherwise I'm totally reliant on my hard copy notebook to make sure I know what I've saved under what name with what.
Right.
Yeah,
Right.
folders. Yeah.
Exactly. It's a precarious situation. And AnyLogic, because of this, has been investing in building a tool. And my understanding is it's going to be rolled out the next version. I was actually expecting for 7.3. Winchell?
Yeah, I think since 7.2, they started to allow you to report in the parameter values and the output intermediate numbers into the database. I think maybe kind of interesting.
Okay. So maybe you could talk about that soon. Okay? Okay.
Yeah, anybody, you can, if you're on 7.2, you can up to the 7.3 that you can go to.
I don't know if we can reload it ourselves. We might have to-
Yeah, they might need IT to install it.
No,
Ellen.
it's PLE.
Yeah, no, like our IT, we cannot install anything on our
Yeah, that's correct,
Yeah.
because
Yeah.
we have no administrative rights for our Windows 7 machines. If we have virtual machines, then we have complete carte blanche with that, but unfortunately, they've taken all the fun, joy, and creativity out of life on our regular machine.
Okay. So I've noticed a lot of times we get this error called widget has been disposed. If you
Oh, really? So I'm not the only one, okay.
No, you're not the only one. I didn't know, I noticed it was the people on 7.2. Some people have 7.3 here though. So, okay.
Okay, so that was 7.2 error?
Seems to be.
Wonderful.
Starting from 7.2.
That's true.
7.2 actually, there's a lot of little.
Yeah, so I hear. I've avoided upgrading to 7.2.
In that case,
Go to
a
7.3.
request to 7.3 and
Yeah.
they'll have to push it out to you.
Yeah, 7.3 I think is quite a bit better from, yeah. Okay, ladies and gentlemen. Okay, so key point, by encoding things as parameters, we can vary our assumptions. And by encoding things as parameters in main, we can vary our assumptions across different experiments, which is very convenient. Okay, ladies and gentlemen, though, we are still off from our mark. And so I'd like to make progress here, okay? Okay, ladies and gentlemen, the first thing I'd like to do, these are building skills that we'll be using a lot in the next few days. All the things we've done so far are going to be skills we'll be heavily applying. Ladies and gentlemen, I would like you now to go to main. And in main, specifically to population. Okay, I should